Okay, so we have gone from this brunasol at the top of the slope in the sand dune to a podzol at this interface between the upper slope and this depressional area. And now we're in this wetland area, which is a bog. And one of the really interesting features of these bogs, I mean, it's got black spruce, but it has this sphagnum moss. And sphagnum moss is really interesting because it can hold 300% its weight in water. And you can just see water just pouring out of here. So you can imagine, one time I think they actually used those for diapers. But I've got water right to the surface here, and it's going to be impossible for me to dig a pit. So I'm going to auger down and see if I can pull out some pieces that will allow to show you the different degrees of decomposition in these bogs. And I've come to sample a little bit of mineral soil here because I'm at the bottom, but let me see if I can find a different spot in the hole to get some more actual peat. And without rubber boots, you'd never make it in here. Well, of course you could, but you'd have wet feet. So here's some nice sample of material. And we'll talk in a minute about what kind of scale you use to look at decomposition of peat material and how to figure out what scale it is. Now, there are special peat bog samplers, and we have one in the department, but I didn't bring it with me today. And hopefully someone else will show you how that works. Okay, we have a couple different degrees of decomposition of organic material here. And what we use to determine how decomposed this material is the von Post scale of decomposition. I should let you know that about 100 centimeters, we actually encountered mineral soil. And so we have this 100 centimeters thick layer of peat over top of mineral soil. And because this is very glade, this would be a CG horizon. So let's start at the top of the profile. This is a sample that came from probably the top 30-40 centimeters. And in order to do the von Post scale of decomposition, you have to squeeze this and look at the color of the water. And if the water comes out clear or partially clear, then you know that this is fairly undecomposed material. And so I would say this is about a 2 in terms of almost undecomposed. You can still see a lot of the fibers and stuff, and so not very decomposed. So let's go now to the second layer, which is a little more decomposed. And again, if I squeeze this, it's starting to come through my fingers, but the water is still kind of clear. And we're probably somewhere moderately decomposed, maybe a 5. But it's not completely humidified. And so that top layer that I showed you would probably be an OH. This is probably an OF. And I'm hoping that this much darker color here is an OH. And we'll just see here if I squeeze this thing. You can see how it just squeezes through my fingers. There's hardly any water coming off here, but this is much more humidified than the other samples above it. It's not a very thick layer, but certainly much more decomposed than the rest of the profile. How do you classify this soil? It's hard because we haven't been able to dig a pit and look at the actual thicknesses of each of these different layers, whether it's the OF or the OM or the OH. So I'm just going to kind of try to make a guess here based on previous experience from being here. But I think the majority of this profile is partially decomposed. And so, and the majority of the profile actually is that. And so I would think then that this is a mesic type of organic soil. And because there's water at the surface right here, this would then be a hydric mesosol. Again, very unique kinds of soils that play an important role but dominate a lot of our landscape in northern Saskatchewan. And we need to understand how these particular wetlands, whether they're bogs or fens, interact with the rest of the landscape. But a very unique place to be, lots of interesting plants and very interesting soils. Let's summarize now what we've seen for this Catena sequence. We started up at the top of the slope on a sand dune. It was an ecosite of a BP2 with jack pine lichen on a brunissolic soil, very sandy. And as we moved down slope, we got to this transition zone where we changed from jack pine tree species to some tamarack and black spruce. We had this beautiful podzol profile there. And then as we moved into this bog here, we end up being in a BP18, which is black spruce, tamarack, treed swamp. And again, this is an organic soil. So huge changes in water have had a huge impact on what we're seeing in terms of soil development, as well as the vegetation communities. And all these things in terms of vegetation, soils, and landscape all interact with one another to create the landscape, the Catena sequence that we have looked at today.